Now, so let's go one step lower or one step higher sa ating discussion in terms of radio access network. Actually, radio access network is very crucial in terms of connectivity, lalo na sa mga areas here in the Philippines, we call it GIDA areas. If you're familiar with the GIDA area, can you type in what is GIDA? GIDA, or the geographically isolated and disadvantaged areas. So these are the locations in the Philippines that are very far from the urban areas. And most of the time, physically isolated sila. And during the digital age, mas lalo silang na-isolate dahil wala silang coverage. They don't have any means of connecting to the internet. That's why they are also called digitally isolated. Okay, so the term digital isolation, digital divide comes in. Sabihin, malayo na sila sa urban area and then they don't have signal at all. Okay? So this is a best example of a GIDA area where it is surrounded by mountains, and before you can access the area, you need to walk or take a boat or take a 4x4 vehicle. Okay. So there's a lot of impact, no? In this kind of scenario. So I believe if you already experience going into this type of area, you will feel some quite of loneliness or sadness na there are still areas in the Philippines like this. And then there are also areas in the Philippines that even water is not locally available, no? Kinakailangan pa nilang bumili from one island to another island. For example, in Masbate, there's a small island, the Zapatos Island, I think. So they don't have enough water there. Wala silang water supply, even though kahit na magukay sila to have a well, they don't have enough, no? So what they do, they buy their mineral water papuntang Capiz, Rojas City. Doon pa, no? So that's very um um nakakalungkot, no, kapag iniisip mo ganun. Anyway, so let's go back to connectivity. Okay, so connectivity is another issue that we need to tackle as an engineers. That's why we are also, when we are discussing radio access network, we are putting this kind of scenario where we can apply our expertise, okay, our knowledge on how to help our countrymen, no, particularly sa Pilipinas. Okay, so this is one of the mission, no, ng Asia Open and Academy. Okay. All right. So in this kind of area, so lack of cellular coverage causes the following challenges. Of course, economic impact. Okay. So there's a lot of issues that's happening here. The lack of connectivity limits, for example, in this area, limits their crop yields and market reach. No? So mahirap magbenta kapag wala kang internet connection. So you need to go physically on the market. No? Hindi mo sila makontak through an online or app. And then social connectivity issues. Okay. Other are emergency services, accessibility, and technological isolation. Okay. So just imagine if we can connect these areas with a simple solution like radio access network. Okay. So you can see that there will be enhanced communication and social inclusion. Okay. Access to information and education, economic empowerment, enhanced public services and healthcare, safety and emergency services, and of course IoT and smart technologies. Okay, so these are the benefits that we could see kapag merong ganyang klaseng wireless network system on those areas. Particularly kahit na yung tinatawag nating telemedicine. Because according to the statistics of DOH, 60% no of the Filipinos who died hindi sila nakakita or nakapag-consult sa doktor. Just imagine that, 60%, no? 6 out of 10 Filipinos died without seeing any doctor. Unang-una, wala silang access sa doctor, which is now mas madali, no? Kasi we have what we call telemedicine. Meron tayong mga applications that you can consult doctor. But in these areas, yung mga doctors natin is although may mga areas that being deployed with doctor to the barrios, but not all areas no kayang i-cover ng mga doctors natin. So that is one of the benefits no kung meron tayong wireless connectivity. We can enhance the communication between the patient and the doctor. So yung ating health sector, we can enhance no yung value na mapoprovide sa ating mga countrymen. Okay? So, what are the different wireless telecommunication solutions? So, balikan lang natin ng konti. So, wireless telecommunication solution, ito yung binanggit ni Ms. Dika kanina. So, meron tayong user terminal, radio access network, and core network. So, whenever we deploy a radio access network or a wireless telecommunication system, kailangan natin lagi itong tatlong to. User terminals, radio access network, and then core network. Okay? Ayan, yung tatlong yan. And then, she also mentioned about the evolution of wireless network, which started from 1G, okay, 2G, 3G, 4G, and now we are in the era of 5G. Okay? So these are the different theoretical speed. No, it depends. The speed is depends no on the capacity and the quality of your RF environment. Okay, it's just the theoretical speed that you can get on an ideal environment. Okay. Okay, so now let's move on to the network architecture. So if you already aware of the evolution from, we will discuss in the 2G, no, starting from the 2G because this is a digital communication. 2G, 3G, 4G, and then 5G. How it evolves, no, from this baseline of wireless communications. So we have the core network, as we discussed earlier. We have the core network, you have the access network, you have the user terminal, and then of course there's an air interface. So we'll start with the core network or sa architecture ng 2G or GSM. So when you talk about GSM, although this is a simplified version of a network architecture. Okay, I don't want you to bombard with a lot of information, but for us to easily grasp the architecture or the network architecture evolution in a one slide, and we can identify the different upgrades that happen. So this slide is one of the best examples. Okay, so you have the mobile switching center, which handles the switching of the calls. Okay, and then you have the controller. Okay, so this is the one that being mentioned in the previous session in the Open RAN deployment, that there is a controller or there was a controller or there is a controller kasi meron pang 2G ngayon that handles the system of GSM, no? So we call it the base station controller. So sa base station controller, all of our BTS or base transceiver stations are connected. Okay, so the handover, okay, so dito nangyayari. And the mobile station, we call it, yung user terminal natin is called as mobile station. Now, there's an improvement happened in the, there was an improvement happened in the 2G. Nagkaroon tayo ng data connectivity, which are GPRS and Edge. Okay, when you say GPRS, General Packet Radio Service, so mga 50 to 60 kbps na speed. So yung when you go to the grocery stores, yung mga point of sales nila na sinuswipe mo yung card mo. So although may mga bago na ngayon which are LTE capable, so the previous versions were operating at GPRS or Edge. Edge naman is enhanced data rates for GSM evolution. Ang maximum speed nito is 384 kbps, but that is already utilizing all the resources in one channel. Okay, so yung 384 kbps medyo malabo. Okay. And then after 10 years, meron tayong evolution na nangyari, which is the 3G. So we utilize the existing components or existing architecture of GSM, okay, especially the MSC, okay, and the packet core. So we call it the CS core, okay, the CS, the circuit switch core, and the packet core, the data. So we introduced a new controller that is called Radio Network Controller or the RNC. And then yung mga cell sites natin are now called Node B. Okay, Node B. And mind you, these are not separate cell sites. Okay, what happened is that the existing tower is being added lang no ng mga additional antennas and radios and then connection dun pa rin sa existing core network natin. Okay, so these are not separate physically. Okay, so we just put this in an architecture para ma-decipher nyo kung what is the difference, no? So the user terminals were also upgraded into UE. Okay, so you need to buy a new phone to enjoy the service of 3G that time. Okay, so UMTS means Universal Mobile Telecommunication Service, and then RNC is Radio Network Controller. RNS is the entire system of RNC and Node B. So we call it the Radio Network Subsystem, and U is the user equipment. So in this technology as well, you will hear the HSDPA, the high-speed downlink packet access, HSUPA, okay, high-speed uplink packet access, EUL for the terminology of the other vendor, enhanced uplink, okay. So dito yung mga marinig yung mga additional enhancement no in terms of the download and the upload. And then came 4G. Okay, so what happens for 4G? We introduce a new core network. We call it the EPC, the Evolved Packet Core. Okay, so this is the EPC. And the Evolved Packet Core is composed of the PGW, Packet Data Network Gateway, Serving Gateway, and the Mobility Management Entity. So all of the control is handled by MME, and all of the user plane is handled by SGW. Okay. And the cell site or the base station is called now E-Node B or the Evolved Node B. And the user terminal is also known as user equipment. Okay? So, sa pagdating ng LTE, so we have a lot of improvement in terms of data connectivity. So, from the typical 2 Mbps, it improved from 14 Mbps, 28 Mbps, but frequently mahirap makakita ng 28 Mbps. Sa 3G. For 4G, they started to introduce around 150 Mbps in the downlink and 75 Mbps in the uplink. Okay. And now we are in the era of 5G. So what happens in the 5G for fast deployments and utilizing the existing core network, we have deployed the non-standalone mode. Okay, when we say non-standalone mode, the additional node B or G node B of 5G is connected to the existing core network. So 5G don't have its own core network yet. So this is the initial implementation of 5G, especially here in the Philippines. And I believe our existing operators and upcoming operators are looking to deploy a standalone 5G. Standalone 5G meaning there is a new 5G core network, which is called 5GCN, that will be connected directly to your 5G G-Node B. Okay, so right now, if you have a phone that is 5G capable, like iPhone 12, 13, 14, up to 15, okay, fully paid or not, if you can see 5G signal, that means your phone is simultaneously connected to the LTE and 5G ng sabay. Okay? We call it the dual connectivity. Okay? ENDC, no? EU-TRAN NR dual connectivity. All right? So, dual connectivity ang tawag natin diyan. And as well as the base station, as mentioned by Engineer Nika, that there's also an evolution in terms of equipment and as well as the antenna system. Okay, so this example from Katrine. So in the previous generations of the base station, the base transceiver station, you will see a lot of big boxes like this, in which the radio transmitters and the baseband are in one refrigerator-like na component. So this is a typical example from Ericsson. And this for Nokia, no? So this is a typical example of ultraside. I don't know if some of you are familiar with this type of equipment from Nokia and Ericsson. And you will see that there's an improvement as well, no? There's an improvement from the form factor of the radio and the baseband unit, and then we separated it. No, not we. They separated it. into baseband, separate baseband and RRU. Okay, so this is the remote radio unit. Okay. Now the benefit of this is that one of the benefits is that you will save on the power budget because you will eliminate the use of a feeder cable. Usually kasi dati nauubos no yung ating power dahil meron tayong cable loss. Now with the use of RRU, remote radio unit, okay? So the radio unit is already on top and then behind the antenna already. So there's a minimum cable loss already. And from the radio unit going to the baseband unit is connected to the CPRI. Okay, so these are the evolution in terms of base station. And now the antenna system also evolved. No? Previously, one band antenna, for example, there's a single band antenna only that works only for example 900 megahertz or 1800 megahertz. So these antennas are separate to each other physically. That's why the towers are crowded with different types of antennas. And as you will see, some of the towers are still uh, crowded, no? And the evolution comes that there's multi-band antennas introduced. So meaning in one antenna, in one single antenna, you can use it for different bands like 700, 800, 1800, 2100, up to 3500, no? So there's a different type of antennas. And then a new antenna solution came in like a MIMO, a massive MIMO antenna. So in which the radio units or the radios are embedded inside the antenna, no? So naggano siya, nagsama na sila. So elimination of the cable loss is introduced. And then there's a lot of beamforming techniques that was introduced in the massive MIMO. Okay. So hopefully we're expecting a lot of antenna improvements as well, no? Pagdating sa evolution ng ating mga cell sites. And not only that, of course, in terms of the mobile, which the users are um, mostly aware, so maraming evolution din in terms of the mobile from the typical panghalo-halo to the snake gamers, no? Up to the smartphones. Yan. Okay, up to the fully paid iPhone 15 Pro Max. Okay, so you can relate onto this, no. Now let's move on to ano, no, to the different some deep dive, no, on each technology. But we will start on the GSM because the 1G is not anymore significant nowadays. The GSM or the second generation, we call it the global system for mobile communications. Okay, so GSM is a standard developed by European Telecommunication Standards Institute or ETSI to describe the protocols of the second generation. So this is a digital type, no, nung first generation. The first generation was analog. Andun yung amps, tacs, no, and the other technologies. So it was deployed in Finland in December 1991, and as mentioned, the replacement of the first generation analog cellular networks and also a digital circuit network optimized for full duplex voice telephony. And as I mentioned previously, meron itong dalawang data transport like GPRS and enhanced data rate for GSM evolution. The logo of GSM is like this, no? Yan, matandaan yung GSM. And this is where we were bombarded by the tedious frequency planning. Frequency planning. Napakahirap ng frequency planning that time, especially if you have limited amount of frequencies. And GSM continuation around the world. So Telstra in Australia shut down their 2G GSM network in December of 2016. So they are the first mobile network operator to decommission GSM. Okay. And the second mobile operator that has shut down the GSM network was on January 1, 2017 was AT&T Mobility from the United States or in the US. And then sinundan siya ni Optus sa Australia. Okay. And then yung pinakahuling update ko is Singapore noong 2017. Yeah. So wala na silang GSM doon. But here in the Philippines, I think ang isa-shutdown natin is, I'm not sure no kung 2G or 3G, but some of our participants can confirm if it's 2G or 3G yung isa-sunset natin. Okay. So yeah, so that is the GSM. No, I don't want to focus on the GSM because we will be focusing on the 4G no and 5G. Okay. 3G ang isa-sunset natin. Okay, thank you Ramil and Joshua. Yan. So now let's move on sa UMTS. So UMTS is the Universal Mobile Telecommunication System. So gumagamit ito ng multiple access which is called the WCDMA, the Wideband Code Division Multiple Access. However, sa GSM, I forgot to tell you, it's frequency division multiple access and time division multiple access. Okay. But for 3G, it's a direct sequence spread spectrum CDMA system. Yeah. So meron tong 3.84 million chips per second over a 5 megahertz radio channel. So CDMA, what is that CDMA, sir? So if you compare the different multiple techniques, okay? So when you say multiple techniques or multiplexing, no? So the purpose of this is to allow several users to share the resources of the air interface because it's limited. So as I mentioned, as mentioned by Engineer Nika, no? So ang frequency is a type of resource, no? Invisible 'yan sa naked eye, hindi nakikita, hindi naamoy, hindi nahahawakan. Pero most of the time, it can be pwedeng manakaw, no? If you are using, for example, illegal repeaters or something like that. No? If your equipment is not type approved by NTC and you're operating on a certain frequency that is not licensed to you, unless it is 4G, it's a 2.4 gigahertz or 5 gigahertz in the Wi-Fi frequency range, no. But if it's in the cellular network, most probably these are owned by existing operators. And if you don't have any license to operate on that one, you are operating illegally. Okay. Anyway, so FDMA is frequency division multiple access. TDMA is time division multiple access. CDMA is code division multiple access. And OFDMA is orthogonal frequency division multiple access. So for 2G, we are using FDMA, TDMA. For 3G, we have a special variant, which is WCDMA. And for 4G and 5G, we are using OFDMA. Okay, so the difference looks like this. So for frequency division duplex, frequency division multiple access, you divide the frequency. Okay. And then for the time, you divide the time. Okay, so for example, in GSM, you have 8 time slots. In one channel, 8 subscribers can use it in a different time slot. Okay. CDMA, you have one frequency, same time, but you have coded transmission. Imagine this if you are inside a bar, you know? If you are inside the restaurant na lang, wag na bar. And then merong malakas na sound system sa likod. And then everyone is talking to each other. So you can see that you can still communicate with each other. But as you talk to each other, the system noise, no? A system noise, aside from the external interference, is getting higher. So ang tendency, people talks louder, no, than usual. That's why minsan pag uwi mo ng bahay, parang bingi ka, no? Parang hindi ka makarinig. No? Sobra yung power na narinig. Yeah. So that is example of CDMA. While OFDMA, okay, so you have a very small subcarriers such as 15 kilohertz subcarriers, no, in terms of LTE. Or for the 5G, we have the flexible numerology from 15, 30, 60, 120, 240 subcarriers, no. So you are transmitting a very small amount, as a very um um short bandwidth, no, that is being transmitted over the air. Yan, OFDMA. Ang tawag natin yan, orthogonal frequency division multiplexing. Okay, so UMTS is using CDMA. Now, the UMTS is also one of the technology that first used the two modes of operation, the FDD and the TDD. Okay, so Engineer Nick already mentioned this, the difference of FDD and TDD. Always remember that in a wireless telecommunication system, there's a two-way or two path, no, of communication. one path from mobile going to the RAN or the cell site, we call it the uplink. So when you talk to the cell site, you call it uplink, no, the path. And then when the cell site is talking to you, it uses the path of the downlink. Now, if the path, no, if those ways are separated by frequency, we call it the frequency division duplex. No, separate frequency for uplink, separate frequency for downlink. We call it the frequency division duplex. So you separate the transmission by frequency. While time division duplex, the uplink and downlink is using only one frequency but separated by time. But the time separation is not um, decipherable by by the human ear. Sobrang bilis ng transition, no, from uplink to downlink. And it depends on the settings kung ilang resources ang i-allocate mo for downlink and how many resources will be allocated to uplink. Okay? So 3G is operating in FDD or TDD. And it depends on the frequency type. Okay? And if you look at the UMTS evolution, okay? So from 2000, we have this release 4 or the release 99. So 3G started with 384 kbps in downlink and 384 kbps in uplink. Okay? And then improvement in the release 5, pinakilala si HSDPA, in which there is a new modulation technique introduced, which is 16 QAM. Okay, 2 raised to 4. No, there are 4 bits that is being transmitted in one symbol. Okay, so there is also a HARC, ACM, and multi-code utilization. That's why the downlink throughput increased from 384 kbps to 14 mbps. But there was no improvement in terms of the uplink, still 384 kbps. Now, in release 8, HSUPA or high-speed uplink packet access, also known as EUL or enhanced uplink, was introduced. If you will see in terms of a naming convention, there is an improvement in the uplink. That's why you can see there's additional uplink modulation introduced. So that is why the uplink improved from 384 kbps to 5.76 mbps. Release 7, there's a lot of improvement. It includes higher order modulation such as 64 QAM, which is 2 raised to 6 bits of data in one symbol. So the uplink of the downlink improvement from 14 mbps goes to 21 mbps, but the uplink still 5.76. Now there's a different feature, no? So the improvement is including the HSDPA plus 64 QAM plus the new technology like MIMO, the multiple input, multiple output. That's why kung gagamit ka ng 2x2 MIMO, you will have times 2 of the 21 mbps. It becomes 42 mbps in the downlink. Uplink still 5.76. Release 8, at the same time, this is the date where LTE was released. Okay? Dual carrier HSDPA. So meaning you will be transmitting dual carrier, 2 carriers, no, of UMTS with 64 QAM each. That's why the 21 mbps becomes 42. Okay? Now, release 8, release 9, dual carrier HSDPA with MIMO. So 42 times 2x2 MIMO, it will become 84. And the uplink will become times 2 rin. No? So 11.52 mbps. Release 10, meron tayong multiple carrier up to 4 carriers. So 4 na carriers na yun ang tinatransmit mo. That's why it becomes 168 mbps and the uplink is 11.52 mbps. But, no, some of the countries or operators are setting down, no, the 3G because nakita nila na mas efficient ang gagamitin nating technology, which is LTE, if we are using the frequency, no, for that such technology. We can achieve this in a 20 megahertz LTE, no? So we don't need to use all of those frequencies into 3G. So mas maganda gamitin natin sa LTE. That's why there are operators that's choosing LTE instead of the UMTS. Now we go to LTE. Okay? So LTE means long-term evolution. So the long-term evolution started from 3GPP release 8, no? Third generation partnership project release 8. So when we say release 8, sir, ano ba yung mga release 8, no? So si 3GPP is one of the influential standardization body. So they are the one who are creating um, the standards and the specifications for the wireless cellular technology. Ayan. Okay, so ito yung logo ng 3GPP, LTE. So sila yung nag-release ng mga logo na yan. LTE Advanced, LTE Advanced Pro, including the 5G. If you will track yung ano yung mga releases niyan. So nung 1992 was the phase 1. That is the basic GSM. Okay, so this is the basic GSM. And almost every year after 1995, meron silang nire-release na mga improvements sa system. And yung 3G, yung LTE was released in release 8, quarter 4 of 2008. And then 5G was released in release, ano yan? Release 13. Okay? Release 13, yes. So, ito yung nag-release no ng 5G. And then release 15 pala, no? Release 15 is a 5G. So that's the 5G phase 1. And then release 16 is the 5G phase 2. Now we are on the release 18. Okay? So 5G advanced. So release 13 pala is LTE Advanced Pro. Okay? So sila yung gumagawa ng mga specifications. So this considered standardization body. Okay, so if you happen to heard about 6G na yung isang certain countries are already have 6G technology, so it's not yet standardized. Kung may 6G sila, that is their 6G, but it's not standardized, meaning they're just proposing or testing some functionalities of 6G technology because the 6G is an overall system. So currently right now the waveform is not yet as far as I know, it's not yet finalized. Not like we don't know if it's OFDM or some sort of variant of OFDM waveform. Okay, so LTE is a 3GPP standard which has a flexible transmission bandwidth up to 20 megahertz. Ano ba yung bandwidth, no? When you say bandwidth, kasi marami nalilitaw sa bandwidth and frequency. For example, if you have a 21 megahertz, for example, when you say, we have an LTE 2100, LTE, sorry no, for the handwriting, dati kasi ako manok eh. 2100 megahertz, okay? And a bandwidth of 20 megahertz. Yan. So, anong pagkakaiba niyan, sir? No? So, some of the students are confused, no? What is the difference between an LTE 21 megahertz with a bandwidth of 20 megahertz? So, just imagine, no? For example, we have a highway. Okay, marami tayong mga kalsada. Okay. So, this could be 900 megahertz. This could be 2100. And then this could be 3500. So, the center frequency or the frequency is the highway itself. Nasa ang lane ka. And then the bandwidth corresponds to the width ng iyong highway. I get my point? So in some cases, no, in most cases, sa mga high frequencies, those are the bandwidths or those are the frequencies where bandwidths are very big. That's why when you transmit on a 3500 na merong 100 megahertz sa bandwidth, you can transmit a lot of data. Okay? So that's the difference, no? But in terms of LTE, you will hear the term flexible transmission bandwidth. Meaning, for the 2G kasi, no, for the 2G, the minimum, the carrier bandwidth is 200 kilohertz. Yan, 200 kilohertz. Yan. For the 3G, it's 5 megahertz. So it's a fixed bandwidth per channel. Maliban na lang ngayon for 3G, there are 4.8, 3.5, no. So it's being driven by the software of the vendor. But typically, when you check out the specification, 200 kilohertz ang bandwidth ng isang channel ng GSM and 5 megahertz ang isang channel ng 3G. But pagdating sa LTE, they make it flexible. So, flexible, no? Iba-iba yung bandwidth niyan. So, when we say iba-iba yung bandwidth niyan, so there are LTE that can be deployed in 1.4 megahertz, 3 megahertz, 5 megahertz, 10, 15, up to 20. Bakit gano'n, ano? There are operators kasi na they don't have sufficient bandwidth. Okay, so for example, sa isang company, sa isang operator na meron lang 900 megahertz na 10 megahertz yung bandwidth niya. So they cannot deploy a 20 megahertz LTE. So with this kind of feature na may flexible transmission bandwidth, operator has the freedom to choose which bandwidth they can use. So they can still deploy LTE in whatever bandwidth they have. Okay? And the peak download data sa release 8 is 100 Mbps. Merong 2x2 MIMO configuration and 50 Mbps uplink. And the round trip time or the RTT is 10 milliseconds, less than 10 milliseconds. And then if you compare it sa spectrum efficiency, when you say spectrum efficiency is gaano ka-profitable profitable ang iyong frequency, no? Frequency is just like a kalsada, no? A highway. So kunyari yung kalsada mo, ang dumadaan dati is puro kalabaw, sinisingil mo ng 5 piso, 5 piso. So you are collecting 5 peso as a toll for those carabaos to pass through. Now imagine if you will use the same highway for a different technology and you will allow cars, bus, no, and jeepneys to pass through, and then you will collect a toll fee around 50 pesos each. So 50 pesos is higher than 5 pesos. No? So it's more profitable is what I'm saying. Okay, so it's more spectrum efficient. Mas marami yung makakadaan. And mas marami yung makakagamit ng spectrum. Okay? So LTE is operating as well in both FDD and TDD. Okay? And have been standardized. Okay? So both allows channel bandwidth up to 20 megahertz. Okay? It uses QPSK 16 QAM, 64 QAM modulation schemes with OFDMA as a downlink and single carrier frequency division multiple access in the uplink. And it supports multiple input, multiple output ng MIMO. And 3GPP release 8 and 9 do not support MIMO in the uplink direction. No? Kaya meron tayong mga bagong releases. So meron siyang FDD, TDD, meron siyang different modulation, and meron siyang advanced antenna system like MIMO. Okay? So yung kanyang modulation, meron tayong mga nakikita ngayon 6256 QAM, merong 64 QAM, 16 QAM, pero pinakamababa is QPSK. Okay? So as you move further away from the cell site, okay? So ang tawag natin dito is adaptive coding and modulation. So when we say adaptive coding and modulation, just imagine meron kang sasakyan, no, nagka-transform. So when you say transform, hindi transformer, no? Transform. It depends, no, on the type of road that you are dealing with. And the road is the frequency, right? Or the spectrum. If the road is lubak-lubak, no? Maraming interference, masyado kang malayo, hindi mo marinig masyado yung signal ng cell site. So you need a more robust modulation. Hindi yung robust na iniinom, no? Robust na, ibig sabihin, rugged. Rugged na lang. Rugged na vehicle, which is a 4x4 vehicle. Naka-engage yung 4x4 vehicle, right? So when you engage a 4x4 vehicle, kahit lubak-lubak yan, even though it's a rough road, you can still drive. You can still go to your destination. You can still reach your destination, right? So that is the QPSK. 16 QAM is just like a Vios type or a Mirage type. Simple type of vehicle, no, na pwede mong gamitin every day, no? Yeah, so Vios, so well, drive ka, maganda yung kalsada, drive ka ng Vios, o kaya Mirage, o kaya Lancer, no? Basta kotse, no? Yeah. 64 QAM naman is medyo mabilis to, mas malaki yung makina nito, no? Pwede kang gumamit ng mga BMW or Mustang. Yan, lalo na kapag maganda yung mga kalsada, TP-Lex. Yan. Sarap mag-ihataw ng 200 kph, no? Yan. Pero huwag kayong magagano, no? Mabawal yun. And then, 256 QAM is yung mga F1, no? F1 car racing. Kasi talagang pulidong-pulido yung RF environment mo, no? Wala kang makikita lubak-lubak diyan. Kasi pag lubak-lubak diyan, bawal malubak yung F1, no? Kasi sira. So that is a typical analogy, no? Kung bakit ka nagkakaroon ng different modulation. It depends on the type of radio environment that you have. Para makarating yung transmission mo from one point to another, from your mobile phone going to your cell site, and cell site going to your mobile phone. Okay? Clear ba yun? Can I get a thumbs up kung clear yan? Okay. So that is the different features, no, ng LTE. But if you look at LTE, kasi ang daming features sa LTE, no? So I'm just selecting some features sa LTE. What else you can see? You can see in the LTE, features ng LTE. Yes, LTE also, we have the self-organizing network, no? Self-optimizing network. So this is where they try to scare the RF engineers and optimization engineers that time. Na, uy, papalitan tayo ng SON, no? And then, when they implemented SON, it's not that kind of intelligent as what we have right now, artificial intelligence, no? Yung SON siya yung nagbibigay sa iyo ng plan for PCI plan, neighbor plan, okay? So it can automate, no, yung mga network configuration, neighbor planning, and then fault finding, and then fault handling. Okay? LTE Advanced starts from 3GPP release 10. Okay? So when we say release 10, so ang tawag nga dito is LTE Advanced. Okay? And then release 13 is LTE Advanced Pro. Pero walang LTE Advanced Pro Max. Pang iPhone lang, no? So LTE Advanced Pro lang tayo. So LTE Advanced, eto maganda sa LTE Advanced. It introduces what we so called CA. CA means carrier aggregation. What is carrier aggregation, sir? Remember na ang maximum bandwidth ng LTE is up to 20 MHz lang. 20 MHz lang. But, no, kung marami akong spectrum, and then I want them to combine, and then to maximize the throughput of my subscribers, okay, or my network, can I combine different types of frequencies, or can I combine different bandwidths? In LTE 3GPP release 10, yes. We call it the carrier aggregation. Okay? So it provides a wider effective channel bandwidth. And then kahit naka-carrier aggregation yan, you can also introduce MIMO, multiple input, multiple output in the uplink, and as well as in the downlink. Okay, mamaya pag-usapan natin ano yung carrier aggregation. Other technologies na nag-evolve, yan. So ito yung kanina pinag-usapan natin for 3G. And then if you look at the architecture ng LTE, it's very flat. So you have the core network. You don't have anymore the controller, the base station controller, and the radio network controller. So in-embed nila yun sa loob ng eNode B. Okay? But right now, if you hear the word Open RAN, which we will discuss in the future discussions, they are putting back again another controller. Okay? We call it the RAN Intelligent Controller. So the RAN Intelligent Controller will be managed or will be assisted by an artificial intelligence / machine learning. Okay, so ito yung network architecture ng isang LTE. Okay. Okay, so now tingnan natin yung different evolutions. So as I mentioned, ang LTE and its evolution started in 2008. So LTE Basic, LTE Advanced is release 10, LTE Advanced Pro, and then 5G na. We don't have LTE Advanced Pro Max, no? Pang iPhone lang 'yan. And then for 5G, release 18 is what we call 5G Advanced. Okay? Yan. So if you look at the LTE evolution, marami nangyari sa LTE evolution. So we have LTE release 8, 9, 10, 11, 12. So it has introduced a lot of scenarios. So there are device-to-device communication, V2V, V2V, no? Or V2X, remote control drones, massive machine type communications, yung mga IoT natin, narrowband IoTs nandyan. And then we also saw densifications, yung mga HETnet, heterogeneous networks, which is a combination of small cells, picocells, femtocells, and macrocells. Multiple antenna technologies like MIMO and COMP, coordinated multipoint feature na para at least maiwasan yung interference. No? Spectrum flexibility like carrier aggregation, new frequency bands, and device enhancement. No? Katulad ng mga receiver improvements. Maraming tayong improvement na nakita sa LTE. Now, if you look at the LTE release 10, so it is a backward compatible upgrade no from the previous basic LTE. And ang carrier aggregation nito is up to 15 components. 5 components, sorry. 5 components. So meaning up to 20 megahertz. So essentially, you will have 100 megahertz bandwidth using the carrier aggregation. And then you have an extended antenna, multi-antenna transmission up to 4x4 MIMO. And then meron tayong tinatawag na relay, LTE relaying. Mamaya pag-usapan natin LTE relay. And inter-cell coordination in HETnet. Okay. And then you have this release 11 coordinated multipoint that coordinates each base station no to mitigate interference. Carrier aggregation sa TDD, sa time division duplex. So in release 11, you can now do carrier aggregation sa TDD. And then meron tayong enhanced control channel structure for the control mechanisms of accessing the resources of the LTE. Release 12 is small cells with features. So sa mga small cells, ito yung mga nakita nyo sa loob ng mga buildings, minsan mga nasa cafe, nasa labas. So small cells are small cell size with low power capability. Okay? And then meron na rin itong dual connectivity. Pwedeng i-turn off and on depende sa number of subscribers. So there's a feature like that. And semi-dynamic TDD. No? And then release 13 is LTE Advanced Pro. In the marketing, we call it the 4.5G. Okay? And then meron tayong license assisted access, LAA. So ang license assisted access meaning meron kang carrier aggregation, di ba? Carrier aggregation happens if the licenses or the frequencies are licensed to an operator. For example, meron akong 900, 1800, I can combine those two. I call it carrier aggregation. Now, paano naman if the operator wants to use a Wi-Fi frequency? Like 2.4 or 5 gigahertz. Now, particularly for 5 gigahertz. Can I combine it with existing 900 megahertz? The answer is yes. Using the feature of the license assisted access. So you can combine those two frequencies by this kind of feature. Okay? And then, na-introduce yung MMTC, the Massive Machine Type Communications. If you're familiar with the use case ng 5G, so makikita nyo, dito pala siya nagsimula, no? Si Massive Machine Type Communications. As you will see the evolution of the wireless communication, makikita nyo yung mga, kung paano nagsimula yung bawat features or bawat new technology. And then eventually, in one evolved configuration or technology, dun sila nag-evolve. And then kung nakita na maganda ang performance niyan, so they are further being developed to be enhanced sa next generation of technology. Okay, like for example, sa 2G, sa 1G is voice, pinerfect yan sa yung voice sa 2G. And then nagkaroon ng data sa 2G, pinerfect sa 3G. Sa 3G, nagkaroon ng further improvement sa data pero pinalaki pa natin sa LTE, no? For LTE, nakita natin, marami pala tayong mga applications like IoT, low latency communications, and then massive enhanced mobile broadband. So, ang ginawa is improve natin sa 5G, yung tatlong yon. And then later on, makita nyo, yung tatlong yon will be further enhanced plus added pagdating ng 6G. Okay, but later on sa pag-uusap natin sa 6G. And then release 14 is the vehicle to vehicle like the V2X, no? Ito yung mga autonomous vehicle na connected sa network. Okay? Yan. So ano ba yung carrier aggregation, no? Let's talk about carrier aggregation in this slide. So carrier aggregation, sabi nga natin, no, meron tayong tinatawag na intra-band aggregation. Intra-band carrier aggregation. So meaning, if you have two contiguous component carrier, meron kang dalawang carrier, so you can combine this. So carrier 1, carrier 2. Yan, pwede mo pagsamahin yan as one carrier. Ang tawag natin dyan is intra-band carrier aggregation. For intraband aggregation, non-contiguous component, ibig sabihin magkahiwalay. Maaring meron ditong isang operator, okay, na kanya yan. Tapos ito si operator 1, operator 1. So pwede pa rin natin pagsamahin yan. Ang tawag natin is intraband non-contiguous component carriers. Okay? Pwede ba sir magkaiba ng frequency? For example, 900 megahertz at 2100 megahertz. Pwede. We call it the interband aggregation. Okay, so nakikita natin yan sa mga LTE na may 900, 700, 850, 2100, 3500, 2600, no, 2300, that operators are combining it, no, using the feature of interband aggregation. Okay, so it depends, no? Merong specification sa 3GPP, what are the different combinations na pwede natin pagsamahin. But what is the best strategy is to identify the user equipment, no, deployed in your network, and then what are the different capabilities of this user equipment, combinations of frequencies. Because user equipment has a combination din in terms of the specification. So you can see the combination where the user equipment can work, no, in terms of the carrier aggregation. Ano mga frequencies yung pwede niyang pagsamahin? And then if you identify that already, so that's the time that you can implement this kind of combinations of carrier aggregation. So that's one strategic approach, no, in deployment of carrier aggregation. Kung itatanong nyo, sir, paano po nag-decide anong carrier aggregation? So your user equipment or your subscriber should directly benefit on the type of features that you will be activating in your network. So sa release 10 is up to 5 component carrier. So 5. Okay, 5. So for example, just a ball figure lang na throughput. Ang isang 20 megahertz, no? Ang isang 20 megahertz with 2x2 MIMO, we can go up to 150 Mbps. Ballpark figure lang. No, 150. Pagpalagay yan, 150. Okay? So if you have 5 component carrier with 20 megahertz, so that is 100 megahertz. So 150 times 5. So that is your maximum theoretical throughput that can get. Okay? Now for the release 11, you can have carrier aggregation with TDD. Release 13 up to 32 component carriers. And release 12 is carrier aggregation of TDD and FDD. But release 13, you can see, 32 components. So that is around 640 Mbps. 640 megahertz. So 32 times 150. So ganun yung ano niya, no? So maximum. But I haven't seen such operator na merong 32 components, no? But it gives you, no, the potential to deploy up to 32 component carrier. Okay, that's why you can hear the word gigabit LTE. So there are LTE networks that can reach 1 gigabit per second because of this type of feature that they can combine multiple carrier. Wala pa dyan yung higher order modulation like 256 QAM and 4x4 or 8x8 PIMO. Okay? Kanina napag-usapan natin itong license-assisted access. We'll just highlight it furthermore. So you have the primary spectrum, which is a licensed spectrum, and then you have the unlicensed spectrum, which is a 2.4 or 5 gigahertz. But most likely, it's 5 gigahertz, no? Yan. So it was introduced, this feature was introduced in release 13. license assisted access. Okay? Ayan. So sa release 14, there's an enhanced LAA to address also the uplink transmission. Ayan. So what else, no? Pinag-usapan din natin last time is the relaying. Okay, so you can relay, no? So you can relay your LTE system. So what you can do is that when you say relaying, it implies that the device communicates with the network via a relay node that is wirelessly connected to a donor cell using an LTE radio interface technology. So this one is an LTE based technology. Okay? So this one is a different cell. So meron kang another capacity dito. It's not a repeater because a repeater is just repeating the signal. But this one is a relay. So in terms of a transmission frequency ang ginagamit mo dito, microwave transmission, you can use an LTE frequency or LTE technology. Okay? You can also use a dual connectivity. So yung dual connectivity na in-implement sa 5G came from this feature. So dual connectivity means you have two separate cell site or two separate baseband unit. And then you can connect the UE into those two base stations simultaneously. Tawag natin doon is dual connectivity. And of course, marami pa tayong mga scenarios na in-implement sa LTE going to 5G. So you have the device-to-device connection. Ang tawag natin dito, kung meron tayong uplink from mobile station or from the user equipment going to the eNode B, we call it the uplink. From the eNode B going down to user equipment, we call it the downlink. Now, if the connection is device to device, you call it the side link. Okay? The side link. Yan. So, ito yung ibang mga new scenarios. Aerial drones. Okay? And of course, the V2V and V2X. Yan. Ito yung mga different scenarios na yan. So, we're going to the transition from 2G, 3G, 4G, and then 5G. That's why we are focusing on LTE and 5G because when we talk about Open RAN, we are focusing mostly on LTE and 5G. Although si Telecom Info Project, they are also tackling about 2G, 3G, 4G, and 5G, the all RAN, no? But in the ORAN Alliance, we're focusing on the LTE and the 5G. Okay. Now, talking about 5G, what is 5G, no? So it's just a glimpse, no, of our discussion because we have a separate comprehensive topic on 5G. So when we talk about 5G, 5G is the fifth generation of mobile communication. We call it NR. If 4G is equivalent to LTE, 3G is UMTS, 2G is GSM, 5G is NR. So whenever you hear NR, we are talking about 5G. Okay? So it's connected to a new 5G core network called 5GCN. And then it has three distinctive classes of use cases: EMBB, massive machine type communications, and ultra reliable and low latency communications. Okay? So when we talk about EMBB, enhanced mobile broadband, meaning it's a broadband connectivity with high data rate and high traffic volume, up to 20 gigabit per second, okay, and gigabytes of traffic. Okay? Massive machine type communications, meaning massive, many. Machine type communications, it's IoT, Internet of Things, up to 1 million devices per square kilometer. So that is the capacity of MMTC. It uses also low cost and low energy consumption. The energy consumption lasts up to 10 years. Okay? Before you change the battery. Ultra reliable and low latency communications, the URLLC. Ultra reliable, meaning up to 99.99, so 6 nines, reliable. So as a minimum downtime in a year. And then also has a lot of redundancy. So you will hear non-terrestrial networks. Okay. So you have a redundancy of connectivity using the satellites. Okay. Comp is also included. Okay. So there's a lot of um, methodology solutions to increase the reliability. Low latency communications, meaning up to 1 millisecond latency response of the network. So that is how fast 5G will become. Okay. So the architecture is also flat, such as LTE. Um, this is a typical example of SA, standalone mode. So this is the holy grail of 5G. This is our destination. This is our objective, to build a 5G network with a dedicated 5G core. If we have a dedicated 5G core, we can go up to these 3 use cases. For now, we have the EMBB. Okay? Partial lang 'tong mga 'to, dahil yung capability ng core network natin. But if we have the 5G core network, we can get these 3 use cases and end-to-end network slicing. Okay? So that is a glimpse, no, of 5G. That's a glimpse of 5G. And the next sessions, probably by the next week, we'll further discuss it deeply. Now, how do we go for technology upgrade, no, in terms of the frequency? Kasi marami nagtatanong ito, no. How do we go for that one, sir, no? For the technology upgrade for frequency, for example, no. Example, you have a 900 megahertz. So you have a 900 megahertz. So the 900 megahertz, probably you have a 10 megahertz bandwidth in a 900 megahertz. So that is from 950 to 960 megahertz. So what you are planning to do, so I still have 5 minutes now. So what you are trying to do, you will divide it into different subcarrier or different frequency channels in the 2G, 200 kilohertz each. So you'll have this kind of scenario. And then you will use this into a broadcast channel and a traffic channel. And then after that, if you want to use this frequency in UMTS, you can use it for UMTS. Okay? You can use it for UMTS, no? And then suddenly you can also use this one for LTE. And then kung gusto mo nang i-sunset din itong ano na to, pwede mo gamitin to for LTE. Okay? So that's how we are using, no? So there's a lot of considerations, no? When you are trying to do a frequency refarming. Okay? So in terms of the physical component, initially meron tayong ganyan dati, no? Per technology, yung ating antenna system, you have a separate system for 900, 1800, 2100. And then we go to a baseband RRU type split of implementation, where you put the RRU near the antenna and the BBU stays at the bottom of the cell site. And then what happens is that yung mga baseband natin is isa na lang yung baseband natin. Okay? And then meron tayong mga implementations where we are using a special type of antenna, which is a dual band antenna, which is pinagsasama natin yung iba't ibang mga frequency bands and technology bands, no? Yan. So ito yung mga sample, no? And then makikita nyo nga yung mga bago implementations, as mentioned nung kanina, meron siyang 12-port antenna. So this is a typical example of a multi-port antenna. So dito is nasa ano lang siya, 6-port, no? Mababa lang. Pero 12-port is something like this, no? Meron lang siyang 12 physical ports. So pinagsasama-sama natin yung mga technology into one antenna. So this is to save space and in terms of operations, no? Mabilis. Yan. Okay. So pwede naman tayong mag-deploy ng ganito, but it's not that kind of meron kasing risk of ano to, no? Operational risk kasi kapag nasira itong combiner na to, no? So most of the time ang ginagawa natin is gusto natin direkta and then wala na tayong loss. Yan. Okay? Ayan.